Yo! This Christmas has been pretty interesting with the rainfall we just had recently. And I'm gonna get into why that is and the cause. For what reason? Well, because it's interesting to talk about, so we're gonna talk about it. So, the imagery you see right in front of you is a water vapor satellite. So, the white and blue colors show areas with moisture, and blue is like the highest color, so highest amount of moisture, and the reds and oranges and yellows are drier air, and the redder colors are just extremely dry air. This imagery has radar imagery overlaid on top of it too, so you can see what that's doing. But I bet the first thing you can notice is the little spinning action you can see that's right over Kansas City right now. And that's a extratropical cyclone, and that's part of the reason of the prolonged lifetime of the rain we first saw uh, on Christmas Eve, and I think for the 23rd as well? I don't remember, but we've had a lot of rain, that's for sure. So we're gonna get into the lifetime of this cyclone right now. So here's the air thickness or air height of the atmosphere. Just like right now, 5.5 kilometers high in the atmosphere generally. So around that height. So this pretty much tells us where the air is higher or lower in the atmosphere, and that's really important when it comes to storms and rain. So here's a cyclone just off the coast of California, and its current motion is going into the U.S. here, and it's got closed circulation, but it begins to die out right here, and it becomes a trough with this kind of flow instead of a circular pattern as it did. But notice a new cyclone forms right here and begins to deepen as evident with the numbers. So 5.4 kilometers, and right here is 5.58 kilometers up in the atmosphere. It's a pretty big difference, a considerable difference in fact. And this is where that cyclone was at its peak. And it's gonna begin to slowly die out after this point. So how did this cyclone form? Well, if we go to this chart, which is air thickness or height in the atmosphere, except for the 1.5 kilometers high in the atmosphere. And this chart shows us warm air transport or cold air transport. And that's very important when it comes to the life cycle of cyclones. So here's that one cyclone off the coast of California. If we continue in time, it begins to disappear. It's hard to see, but there's a little trough right here, as evident by the numbers. You can see it lower right here. But one thing to take note is this little glob of cold air transport that's being brought down from Canada. And this is going to be very important, as you will see in a second. So if you think of the phrase cold air sinks and warm air rises, you can pretty much understand what's going on here. So as the cold air gets transported into a different region, like what it is doing right now, it's in the process lowering the height or thickness of the atmosphere, and that helps deepens a cyclone or a trough. And here you can see a closed circulation that just formed right here. And as it strengthens, it begins to start moving warm air to the opposite side of where cold air transport is occurring. And as this happens, it begins to pretty much strengthen the cyclone, with the cold air deepening it, and then the warm air is just making a much abrupt change of thickness, as evident with these lines. They're much closer than what these lines are. So these two are actively helping sustain this cyclone. But if we continue in time, all the transport just went away. And now you can see it begins to weaken. There's not as much lines, and the numbers tell you that it's a lot higher than it used to be. Like, it got as low as 1,350 meters. And it increased up to 1,380. Screwing up my numbers here. Too many numbers to look at. So at this point, this cyclone is pretty much doomed. It's gonna start to weaken, and it will no longer begin to strengthen. Now we're gonna get to the surface map, so you can see cold fronts and warm fronts. This is 12 a.m. for December 24th. Here you can see a cold front, currently unrelated to the massive tropical, extratropical cyclone that we just discussed. But you can see this cold front begins to move over the border of Minnesota and moves into Minnesota. This is 12 p.m. for Christmas Eve. And what's going on here is the cold fronts, they're essentially pretty much like a wedge of cold air moving like this. So what happens is when it moves over, moves to an area warmer, or replacing warmer air with cold air, it begins to force up warm air up into the atmosphere. And mind you, also moist air as well. So when that moist air goes up, it'll begin to condensate and create rain, clouds, all that stuff. Hence why we had quite a bit of rain for December 24th. And it continued. We're now going into December 25th, Christmas Day at 3 a.m. And there is still rain occurring right now. And here's the massive cyclone that we talked about earlier. It's right here on the surface. It got this deep. I lost my place for a second. It got this deep in the atmosphere, and now this is 6 p.m. Then 9 p.m. another cold front. Again, it forces up more warm and moist air, prolonging this rainfall. And you can notice it's I believe that's purple, and that essentially means the cold front overtakes the warm front. So warm fronts essentially move over colder air, kind of like this. It moves over it like that. And so when a cold front overtakes it, it pretty much just forces it up. All the warm air. And then you got that, like a little pocket of warm air, and generally a lot of moisture as well too, with clouds and rain. So this was pretty much why we had just so much rain. We just had a low pressure system right here give us a pretty much an appetizer of rain. And then the giant extratropical cyclone comes into play and just forces up a lot of moisture and creates a lot of rain and clouds. Here you could, there's on the radar imagery right here, there's not a whole lot going on anymore. That pretty much tells you that it's just at its peak and it's starting to slowly die out. So that's why we had a lot of rain, and that's why the rain was pretty much prolonged. It's because of this massive cyclone right here. Yeah, that's all I have for you. Hope you learned a thing or two. And that's it.